go back down to the decisions area, and now that the monster knows that he can successfully, or probably successfully, make the jump, let's give him a -12 velocity to activate the jump, and we'll use monster jump so he's actually doing a jumping motion if it's available. And you can see here in monster jump, it'll set this motion to jump. It'll say he's no longer on the ground, so the ground logic no longer applies, and it'll play the regular jump sound for that because we're not doing a bouncer, and we don't have to worry about must finish animation. And then of course down in our update, it's going to see that the motion has changed, and it's going to start the jump animation. So there's a solid wall in the way otherwise, because he checked to see if there's any empties. He goes, oh, there's nothing empty there. It's just a big solid wall. So I guess I'll have to go the other direction. So he's going left, which would be negative value. Instead of randomizing, we'll just set it to +4, and then it'll sort itself out after that. So I just put this comment here, solid wall to the left, so go right. Now, we checked for solids. What we didn't check for is spikes to the left. So else if it is a spike, then we're just going to change the velocity to the right automatically because he doesn't want to take a chance with the spikes. Now what if to the left of him there's nothing, but there might be a space that he might fall down onto, or it might be a long drop and you might want to not jump that far. He might take a look to see if there's something he can jump down onto. So we'll check to see if there's something solid he can jump on. We'll say is solid using an integer because there could be a few different scenarios for what's there. And we'll create something called contains solid, checking to the left. This time we'll say y+1 to y+5. And then once we know this status, what number this is, we can determine what's going on with the tiles down and to the left of him, and then he can figure out what to do. So we'll go up to where we had the contains empty. We'll copy that and create another tile, or another helper, and we'll call this one contains solid. We'll have to change our return type to integer, and by default we'll return 0, meaning there's nothing there. This stuff's all the same. We want to make sure that we're scanning down and that it's not off the map. So what we'll do is if xy is solid, we'll return 1. However, if it spikes, that's a slightly different scenario, we'll return 2. There's a chance that it's not solid, it's something you can stand on, like one of those platforms you can jump through. So we'll also return 1 for stand on. In fact, it'll probably see that before it sees is solid, so I'll put that first. So test a vertical strip of tiles to see if there's a solid tile that he can land on down and to the left of him when he jumps or runs off the edge. And if it spikes, the monster's not that dumb. Okay, go back down to the wander section, or runaway section. I just put this label here, something to jump down onto, and one here too. Solid wall to the left. Makes it easier to identify what these are for. So if there's nothing there, then we'll need to change directions because it's too far to jump down. Otherwise, if the solid is 2, that would be spikes. So he may try to jump over them. So we'll accelerate him even faster to the left. Stop Y and have him jump. And we'll have to call monster.jump. So the tips of the spikes would be kind of either be in line with him or below him. So there's a good chance he'd be able to jump over them. So he might give it a shot. Otherwise, if his velocity is greater than 0, he's going right. Then we'll just do the same thing, except we'll make everything tile +1 basically. So let's just copy this here and paste it in here and just make some adjustments. We could also make a call to a method, shrink this code, but we wouldn't really be shrinking it much because we'd be just expanding our module even more. We'd shrink it a little bit. Change this to +1, this one to +1, same here, +1. We want the velocity to go -4 here, and same here too. If there's a spike, go the other way, not safe. +1, check to the right, and in this case there's nothing to jump down onto, so go back left. There's spikes in that direction, so accelerate and jump. I just had a bug here, so we'll just go up to the top of wander, copy this break out of here, it's not in the right place, and put it down here. Control decisions will be a little simpler because he's not really trying to navigate terrain, he's just trying to guard a section of terrain. So if the target velocity.x, if he's going left, then we'll say if there's a solid to the left of him, or there's nothing to stand on to the left, or there's spikes to the left, then we should go the other direction. Target velocity.x, and we'll randomize the velocity. Next 3 times +4, and then we can copy this, change this to else, see if it's greater than 0, and at +1, and there's nothing to the right to stand on. Either there's a solid to the right, nothing to stand on, or a spike to the right. Then we need to change directions. Instead of +1, this will be -1 or -4. We don't want to pick a random speed in general because that spans from negative to positive directions. So we just want a specific direction with some sort of randomized speed. So that's it for patrolling. He just keeps going left and right until he encounters something he doesn't want to step on or fall off of, and then he goes back the other direction until he changes his mind about whether he wants to patrol or wander. So these are decision modes that only are ever triggered while he's on the ground. In either the wander or the patrol mode, it's possible he may want to chase also. Rather than creating a distinct mode, we're just going to create some decision behavior within those modes based on how far away from the player he is and whether or not he has the courage to attack him or he gets scared and has to run away. Before we do that though, these sections are getting a little bit large, so I'm going to divide this up into regions so we can just close regions as we don't need them, and it'll make it a lot easier to navigate the code. So this is region basic motion changes and region. Then we can just shrink that. This will be decisions. Say and region, and I might want to say on ground. This I'll leave open because it's fairly small. This will be fairly small too, but I'll make it into region anyway. So region, determine chase, and this will be active when we're either in the mode for wander or patrol, and it doesn't care if he's on the ground or if he's jumping or whatever. That's what this section's for. So if we're on wander mode or the mode's patrol mode, then he might want to attack the player. If position.x of this monster is greater than the player.y, or the player's position.x minus, based on the resolution, character size, which is all going to be staying the same, static, because it's a desired target, say minus 220. So if he's within the general region of the player, within some sort of proximity, we don't really need to rescale these values. We'll do the same thing vertically too. Vertically it'll be a bit different because of the aspect ratio of because of the dimensions in the vertical direction of your display are different than your horizontal. So if greater than player position.y minus 150 and position.y somewhere less than the player position.y plus 150, and this would be kind of like a rectangle intersection test, except we're explicitly saying whether he's within that sort of rectangular region. So he's within range, that means the monster can give chase. If the position.x is less than the player's position, then we'll have him move to the right to get closer to the player. So we'll set his target velocity to be +6. But if his position is to the right of the player, he needs to go left. So we'll set the target velocity x to be -6. Another possibility, he could be in runaway mode, mode.runaway, if his position is less than the player position. If he's to the left of the player, we want him to move away from the player in that direction. And if he's to the right of the player, we want him to move further to the right to get away from the player, so running away. And eventually, we might want to add extra logic in here too to have him escape particle emitters. So not any particle emitter, but spells in particular. So he can compare his position against a radius for the particle spell, like the fireballs, and determine if he's within distance that he needs to try to dodge, and then he just move away from the fire if he can. So go back to the Monsters4 class. In our editor, we would like to be able to delete them from the map. So under add monster, let's add a delete, public void delete. So we'll say integer I equals 0, just like we did up here, and we'll say while I is less than the number of monsters, and I++. And what we'll do is we'll check to see if the location that the monster is at, so we'll probably only use this with the editor, is the same as the map location. Yeah, we'll only be using that with the editor because we already have a way to flag it as dead. Say A is equal to I, while A is less than the number of monsters, -1. So for the index I, we found a matching location. There is this monster existing at this location, and we want to delete the monster at that map location. So what we'll do is we'll shift the list back 1 and delete the last entry since it became a duplicate of the second last one. If monsters A plus 1 is not equal to null, so there is a monster in the next slot, then we're going to say monsters A equal to monsters A plus 1, else break. We don't have to use any kind of looping array or anything because there's not going to be that many monsters that this would ever cause any slowdown. Say monsters A equals null. So that monster does not exist anymore. Besides which, we're just using this in the editor anyway, so we don't have to worry about super high efficiency in the editor. It would be total overkill. What I really wanted to get to, though, was to start the update in Monster4. So public void, this will be very short actually. Taking game time, update AI, true by default. So we'll loop through the monster, or the monsters, while I is less than number of monsters. If monsters dead, then we just continue, I++ and continue. Then we'll call the update method for the monsters themselves. And from here, we'll also call a world collisions. And I'm just going to put the world collisions right in the monster class instead of spending a bunch of time setting up something separate. While we're in here, we may as well add a draw method too. Void draw. We'll use the quad batch one that we passed in, and we'll use no motion texture, which contains all the monsters. Blend state alpha blend. Doesn't know what I'm talking about. Resolve. There we go. Sampler state linear clamp. Depth stencil state none. Quad batch.end. And all the rendering actually happens in the end call. That way it does it all at once. It's a little more efficient. While I is less than number of monsters, I++, and if it's not a dead monster, then we can render it. Otherwise, that wouldn't make sense unless we had an image of a dead monster, like some flowers or something popping out of the ground. And we'll have to create a world collisions and a draw method next in the monster class. We'll go back into monster.cs, and as we've seen in Monster4, we want to call the update first. Update's going to call update AI to make some decision changes, whether it wants to chase or do random changes, make decisions based on terrain. The thing is, the monster can make decisions based on terrain, but has no ability to actually collide with anything yet. So after it calls the update, it's going to call world collisions. We'll put world collisions right after update. Public void world collisions.